record. So let's just start here. We're going to find polynomial equations. These are the answers. These answers had to come from a polynomial that was factored. After it was factored, you made your mini equations, right? Then you solved your mini equations and you got these three answers. So these three answers came from mini equations. So if I know that x is equal to 3, then x yes, that makes sense. So one of my mini equations to get 3 would be, I totally agree. And if I have an x equals -1, then it really had to have come from x plus 1 equals 0, right? Because I go -1, -1. Everybody okay on that?
Yes, I agree with that.
And then finally, if I have an x equals 2/3, I would have had a 3x equals 2 or a 3x minus 2 equals 0, right? So to get these three zeros, I would have had to have these three mini equations. So in a polynomial, I would have had a x minus 3, x plus 1, 3x minus 2. Okay, this isn't too hard. I can do this. And now I want the original polynomial, so I'm just going to multiply it out, right? I'm just going to go, I'll do this times this, right? I'll do all that. So I'll go and get a x squared plus a 1x minus the 3x minus 3, which is an x squared minus 2x minus 3. And I'll slow down and wait for you, okay? So I knew my three answers. They came from many equations.
Wait, how did you get the, hold on a second. Can you slow down for a second?
Yep. I don't mind. I try not to go too fast.
Why didn't you multiply it through to the 3x minus 2?
I'm going to do that next.
Oh, you're just doing it step by step?
Right. So let me give you a super easy example of why I'm doing it. 2 times 3 times 4, right? 2 times 3 is 6 times 4, right? That's all I did. You don't want to go 2 times 3 and 2 times 4. Wrong. You got totally wrong, right? You could go 3 times 4, then times 2. But you got to multiply 2 of them first. And then, Cassidy, I'm going to multiply the third one, right? So now, I'm going to then multiply. And so I'm going to get a 3x cubed minus 2x squared minus a 6x squared. I like to line them up. It makes it easy for me. Plus a 4x plus 6. My original polynomial would have been 3x cubed minus 8x squared plus 4x. I must be missing one. Minus 9x. Darn it.
Wait, what about the plus 6?
Well, I got that, but I missed one. I missed that one right there. Shoot. Minus 5x plus 6. Yeah, that's a negative 9x. Sorry. This is the equation that has those zeros.
Just kidding.
Okay, this is the polynomial that has these zeros. It probably factors into that. Pretty sure.
This isn't too hard.
No. Okay, now, example 2. Before I do example 2, I want to show a graph of example 2. And so if I had 2, -3, and 1/2. Okay? Right? Wrong. 1/2 was there. Wrong. Golly, don't you love it when I make mistakes?
Everybody makes mistakes.
I know, I do probably more than most math teachers. It's all good though. Well, come on in.
Hi, Tanya.
Hi, Tanya.
You have a note for me?
I don't.
Tanya. I know, you're like, I was already here. Why am I
Yeah.
coming? I know, I get it. All right, Madison, I got a Smartie for you. Brian and Retta, but I'm filming, so let me give this to you real quick because I'm filming. I don't know.
Because you're smart.
Oh, your book. Oh, buy your book early. Okay, go ahead. So,
Because I wrote it in a yearbook?
I guess so.
Oh my god.
Wow, that makes the $65 so worth it.
Okay. So watch. You guys watching? So, hey, watching? This is important. I know Valerie is kind of watching. Kind of.
I've been one.
So check it out. Here's my polynomial. Right?
Most likely.
Yeah.
Maybe. Or maybe this is my polynomial.
Maybe somewhere.
Maybe this is my polynomial.
No. No, you're right. That makes sense.
Maybe. Which one is it?
You know what's funny?
Well, I need another piece of information. If it goes to point 0.2, then it helps me figure it out. Okay?
Why do we need to draw this? It doesn't say to on the page.
Correct. I agree, but it gives me understand why. Yeah, let's see.
You don't know what it looks like. It just goes to the-
Bro, that means it's a joke.
Now, since I have a point, the polynomial I'm trying to find has to be very specific. So, let's start here. I have many equations, x equals 2, which came from an x minus 2 equals 0. I have an x equals a negative 3, which came from a polynomial x plus 3 equals 0. I have a 0 of x equals 1/2, which came from a mini equation 2x minus 1 equals 0, okay? What I want to do is find the polynomial that goes through the point 0,2. So what I have is this. I have a p of x equals, and, okay, now, again, what I want you to see is this. After you stop talking, I want you to see this. I don't know. I don't know. This, from what I have so far, my polynomial could go like this. We have no idea. But we have to force it to go through that point. Because it has to go through that point, because we know it goes. To force it to go through that point, I plug the point into my equation.
How would you do that?
Now, here's what I do know. I know there's always some number here that either makes it upside down if it's negative, or right side up if it's positive. I know this number here, whatever it may be, can make it either really tall or really short. I need to know this number here. It's my coefficient. I don't know what my coefficient is, but I'm going to find it by using this point in my equation, okay? So I have to find the value of A. I have to find the value of A. So to find the value of A, I'm going to plug in some point. But the point I want to plug in is the 0, 2, so that I force the graph to go through 0, 2. All right, so every point has an x and a y value. So we're going to plug my 0 in for all my x's, and we'll plug my 2 in for my y. So I'm going to rewrite this as 2 equals a times 0 minus 2, 0 plus 3, and 2 times 0 minus 1. We want to find the value of A. And we need to find the value of A because it will give the shape of the curve. It'll also make the curve go through the point 0, 2. Yes?
So, for whenever, in any equation, when it says, like, passing through a certain point, it's, you always just plug it in for the
X
y.
and a
You do it
y.
every time?
Yes. Yes. Okay, let's simplify. We can get the value of A, right?
That's 5.
2 equals A times a negative 2 times a positive 3 times a negative 1. Let's simplify a little bit more. A is equal to a negative 2 times a 3 times a negative 1 is a positive 6.
No, wouldn't it be a negative?
Well, this is a positive 3. Somehow my pen is running out of ink, and it looks like an... Yeah, my pen's running out of ink. Divide by 6. So the value of A is 1/3. Okay, now my equation then, I'm going to take my 1/3 and put it right there. So I have an equation of y equals, or f p of x, 1/3 times x minus 2 times x plus 3 times a 2x minus 1, okay? And if I wanted to get the polynomial, I'll multiply it through. Okay, so let's go ahead and get the polynomial, so I'm going to multiply it through. I'm going to do something a little different this time because I like to do this. You'll see why.
Why do you do the least?
Want to do what? Yes. So I'm going to multiply these two together first. Just makes it easier for me. So I'll keep my y equals 1/3 times x minus 2 here. Actually, I can make that a 1/3 x minus 2/3, but either way. So I'm going to get a 2x squared minus a 1x plus a 6x minus 3. I'm going to make that a 1/3 x minus 2/3. I may as well bring the 1/3 in because I have to anyway. My pen's dying on me. I should just chuck it. So then I'm going to have a 2x squared plus 5x minus 3. I just combined those two terms. Now I need to finally get my answer. That times that, that times that, that times that. I'll get a 2/3 x cubed. Yes?
Can you slow down a second?
Yeah. So I foiled these two into this. Okay? I foiled these two into 2x squared plus 5x plus 3. And I wanted to get this 1/3 taken care of, so I brought the 1/3 in, okay? Cassie, give me thumbs up when you're ready. Now I'm going to go this times, I'm going to go this times this, this times this, this times this, and I'll go this times this, this times this, times this, and I'll have my answer, okay? So, 1/3 times 2 is 2/3 x cubed. 1/3 times 5 is 5/3, so I'll have a positive 5/3 x squared. 1/3 times 3 is a negative 1x. Then I'm going to multiply here. I'm going to get a negative 4/3 x squared. I'm going to get a negative 10/3 x plus 6/3, which is 2. Okay, so then finally, I'm going to get y equals 2/3 x cubed plus a 1/3 x squared minus, that's like 3/3, that's like another 3 is going to be 3, negative 13/3.
How did you get 13/3?
I'm going to show you. I'll show you.
I can't do this.
Yeah, you can. Yeah, you can. Yeah, you can. Is negative 1 the same as 3/3?
Yeah,
Common denominator. What do we got?
yeah.
Now, this is my answer. So before I go any further, let me take my answer. I want you to see this. Okay? And if I do this, where's my phone? I want to check this out. I do. I want to check this out. Let's see what I got. Hold on. Face ID. I don't want that. I want Desmos. Hold on. Come on. Come on. Come on, phone. Just stop messing with me. All right, there we go. School, Desmos. All right, check it out. You guys watching? Y equals 2/3 x to the third power plus 1/3. Oops, back. Ugh. Oh man, I'm really messing this up. Shoot, clear this. Clear. Okay, I don't want that. Okay, get rid of it. Do it again. Y equals, I want to show you this. Ugh.
Don't we have to do this on the test?
No, but I want to show you something. I do. I want you to see this. Y equals 2/3 x to the third power. Okay? Move it over arrow. Now, plus 1/3 x. Oh, crap. I'm not going to show it. But it will go through the 0.20. Okay, ready to turn the page? That was frustrating, okay? Now, finally, let's do this one.